All right, today we're doing section 2.6. It is about properties of equality and congruence. We are going to use properties of equality and congruence. Here are the warm-ups. All right, for our warm-ups, we are just solving equations. Kiatha, what'd you get on number 1? Wonderful. We should get x equals 9 if we divide both sides by 3. On number 2, Angel, what did you get? Angel A, sorry. X equals negative 23, but you subtract 6 from both sides. On number 3, Sydney, what did you get? Wonderful. On number 4, John, what did you get? Okay. All right, let's go through number 4 together. Instead of dividing by 2/3 on both sides, we're going to multiply by its reciprocal. Who can tell me the reciprocal of 2/3? 3 over 2. When we do that on the left, it's all going to reduce to 1. So we're left with 1x. On the right, we take 6 times 3, we get 18. And then we have to divide by 2. So x equals 9. Wonderful. We get x equals negative 4 for number 5. The first property of equality and congruence we have is the reflexive property. So that's already written there, underlined for you. So we have the reflexive property of equality and the reflexive property of congruence. So for the reflexive property of equality, we are talking about measures being equal to each other. The reflexive property states that anything is equal to itself for equality. So the length of AB is equal to the length of AB. For congruence, it's very similar, except this time we're talking about objects being congruent, which means that these ABs here should have the bar over the top of them. Segment AB is congruent to segment AB. The reflexive property is the easiest one. Anything is equal or congruent to itself. The next property is the symmetric property. Again, we have symmetric of equality and symmetric of congruence. Down on the symmetric property of congruence, we should not have the m's out in front of the angles. So I'm going to change that on the slide real quick. It should just say angle A and angle B. We only use the measures when we talk about equality, not when we talk about congruence. There are small differences. Okay, the symmetric property states that you can make a statement forwards or backwards. So if AB is equal to CD, then you can also say that CD is equal to AB. You can flip it around. Same thing with the measures of angles. Same thing with the congruence statements. The transitive property is the most involved. For equality, we have 2 statements in the beginning. If AB is equal to CD and CD is equal to EF, then AB is equal to EF. We used this kind of idea last Friday when we did the laws of syllogism. Right? We cut out the one that was the same in the middle. We went straight from the beginning to the end. That's kind of the same thing that we're doing with the transitive property. We're cutting out the part in the middle that was the same. It works for equality and for congruence, angles and segments. So 1A we said is the transitive property of congruence. How did I know that it was congruence and not equality? Anybody? What sort of symbols did I see in between? Those are congruent symbols because it has the squiggly line over the equal sign. That's how you can tell the difference between congruence and equality. A congruent symbol has the squiggly line over it. An equals sign does not. All right. Letter B said that we have FG equal to HJ. Then we know that HJ is equal to FG. David, what property is that? Symmetric property of, what kind of signs do we have?
Which one are we on?
Letter B.
Equality.
Symmetric property of equality, I agree. Okay. And on part C, we have that angle C is congruent to angle C. Joel James, which one do you think that is? Letter C would be the reflexive property of congruence. Anything is congruent or equal to itself. Wonderful. So they gave us information in the beginning. We were able to use a property, in this case the transitive property, in order to show what they wanted us to. So AB is congruent to CD by the transitive property of congruence. My recommendation on these types of problems, if they give you a diagram and they have not marked it yet, is to start marking it with what you know. So they tell us that N is the midpoint of MP. What does that mean about segments MN and NP? They're congruent. So I can mark that in my diagram, and I could also say that down here. I know that MN is equal to NP because of the definition of a midpoint. Okay, so I know that that's true. They also tell us that P is the midpoint of NQ. So what does that mean for NP and PQ? They're also congruent. So if I used one tick mark for NP, I can use one tick mark for PQ. Those also have to be the same. So I again can make that statement. NP has to be equal to PQ. Same reason, definition of a midpoint. So what I'm doing is listing what I know and how I know it. So our last thing that they want us to do is show that MN and PQ are equal. Well, we can see that in our diagram now, but we have to be able to give a reason for stating it. So MN equal to PQ. If I look at these other statements I just made, what property does it look like I'm using? So I said MN is equal to NP. NP is equal to PQ. Cade?
Symmetric.
Symmetric only involves two objects and you just switch the order of them. Yeah, here it's the transitive property of equality. We cut out NP, cut out the middle. We went straight from MN to PQ being equal. So this one we know by the transitive property of equality. And then that's it. That's what they wanted us to end with, MN equal to PQ, and that's what we showed. We already know these, but the addition property of equality states that adding the same number to each side of an equation produces an equivalent equation. The subtraction property of equality states that subtracting the same number from each side of an equation produces an equivalent equation. You used these properties in algebra and earlier in the warm-ups. That's how you solve equations, is using these properties of equality. The multiplication property of equality states that multiplying each side of an equation by the same non-zero number produces an equivalent equation. They put that in there because if you multiply both sides of an equation by 0, the whole thing goes to 0. 0 equals 0. That doesn't really do us any good. The division property of equality, dividing each side of an equation by a non-zero number, produces an equivalent equation. This time we had to put the non-zero part in because you cannot divide by 0. Doesn't work, messes everything up. So that is why it's included in that property. The substitution property, again, one that you've used many, many times in Algebra 1. Substituting a number for a variable in an equation produces an equivalent equation. Okay, example 4 says that angle 1 and angle 2 are both complementary to angle 3. So I want to start off by making a couple statements about that before I even worry about what they're asking me to show on the end. I want to make some statements using the information they give me. If angle 1 is complementary to angle 3, then I know that the measure of angle 1 plus the measure of angle 3 is equal to what, Julian? So the measure of angle 1 plus the measure of angle 3 is equal to 90. I know that by the definition of the word complementary. Okay, so we've dealt with angle 1, but they told us angle 2 is also complementary to angle 3. So I can also say that the measure of angle 2 plus the measure of angle 3 is equal to 90. So these have the same reason. Both of them are by the definition of complementary. The next part is the one that gets a little weird for some people, because usually in algebra we would go in a different direction, but if both of these are equal to 90, then that means we can set them equal to each other. The measure of angle 1 plus the measure of angle 3 is equal to, instead of putting 90, I'm going to put this expression that equals 90, the measure of angle 2 plus the measure of angle 3. Now that's not usually how we see substitution, but it is using substitution. So we substituted in an expression instead of using 90. Again, the next part, some people might not like a whole lot, but this is why we went through our properties of equality. So my next statement is going to be that the measure of angle 1 is equal to the measure of angle 2. What did I get rid of on both sides? The measure of angle 3. What operation do you think I used to do that? Don't make it harder than it is. Instead of adding the measure of angle 3 on both sides, what would I do to get rid of it? Subtract it. So I use the subtraction property of equality. Or you can just put subtraction. If I subtracted the same thing from both sides to come up with my next step, I use the subtraction property of equality. And we're almost done. They wanted us to show that angle 1 was congruent to angle 2. I don't have a congruent statement. I have an equality statement. But I know that if two things are equal, then they must be congruent. That's the definition of congruence. And that's it. That's what they wanted us to show. So we went through all the steps, gave all of our reasons to end up where they asked us to.